Welcome to Mathematics with Tom. I am Tom, and today we are going to look at the Fundamental Theorem of Calculus, part 1 of 2. And before we do this, writing Fundamental Theorem of Calculus it's a lot to write, so you'll often see it abbreviated, and we're going to use that as FTC, Fundamental Theorem of Calculus, FTC. And here's what it says. It says if f is continuous on the interval, we're going to use a closed interval from A to B, and capital F of x is equal to the integral from A to x of f of t dt, then the derivative of capital F, so the derivative of capital X with respect to x, is equal to f of x. That's what we have to prove. First thing, notice that, just to be clear, I wrote the derivative of capital F as derivative with respect to x of f of x. You'll also often see this written as df dx, and sometimes you'll even see it written as f prime or f prime of x. Okay, so there's some just general notations that are used. Let's try this. Let's make this proof. So what this says is that we have to find, somehow we need to take the derivative of capital F. So that's what this whole proof says to do. It says find what it's really telling me to do is find the derivative, find f prime. Well, let's just write it that way, find f prime. All right, let's do that. Well, remember what the derivative of any function, what this says is that the derivative, f prime of x, is equal to capital F of x plus delta x minus capital F of x over delta x. Oh, and I should have written that a little bit more clearly. Let's put a little bit of space in here. Here's how I'm going to do that. Hopefully, there. And so this is really, it's the limit as delta x goes to 0 of that. And sometimes you use an h instead of a delta x. Either is fine. But let's try this. So what this says is, notice what capital F is. So capital F is up here above us. It's this integral. So we have to plug x plus delta x into capital F. So this becomes the integral from A to x plus delta x of f of t dt minus the integral from A to x of f of t dt. And all of that then is divided by delta x. Okay, well, this is kind of difficult if you think about it. So let's try to see what just happened and we're going to get a better intuition for this. So here's my graph of f. Like that for the sake of illustration, and we're going to integrate from a to like some x. So let's do this. So if I integrate from a to x, this would be f of x, this area in here. Okay, now look at what I've done though. I'm going to take that white area, and I'm going to be subtracting that from, let's do this nice kind of greenish area. Well, if I go over here to x plus delta x, that's going to be x plus delta x. And this is this is t, and this is f of t. Well, what happens now? So this says, this green region is all of this. but all of the green region is f of x plus delta x. But when I subtract them, well, what do I get? That subtraction would just give me this blue region, this nice pretty blue. Well, that's just this piece in here. Okay, so our whole focus now has changed, not from the white, not from the green, now we're into this blue region. Also has the vertical stripes. So these vertical stripes are our new region that we want to consider. So let's think about this. So in other words, I can rewrite f prime. So f prime of x is now, well, this blue region is the integral. I'm going to write this way, the limit as delta x goes to 0 of, I'm going to write it as 1 over delta x times the integral. Now we're from x to x plus delta x of f of t dt. Now this may not look very helpful at this moment. So what we need to do is we have to be clever. And here's how we can be clever. If you recall, there's something that was called the mean value theorem. I'm going to abbreviate theorem of integrals. And what that said is that you could approximate, it says that there exists, so there's some c in your interval, so some c in this interval going from x to x plus delta x, there's, oops, should be closed, some c in there that such that you could pick c. So I'm going to make this orange here. So I'm going to put this c maybe right here. So this is my c. Then there's some height over here. This is f of c. And what the mean value theorem says, that this blue region, there's some c in there that'll work just perfectly so that you can form a rectangle and just multiply this, the base times the height. So if we write that out, what that says is that there's some c, f of c, that's the height, times the base. Well, the base is x plus delta x minus x. Well, that distance there is equal to the area under the curve. Well, that area is from x to x plus delta x f of t dt. So we know that there's some c that gives us the answer. Well, now let's think about this. If I clean this up, x plus delta x minus x, well, that's just delta x. So now I have that f of c delta x is equal to this integral of x plus delta x f of t dt. Now I'm running out of space here. That's okay. We'll go to another screen when it's necessary. But look at this. This says that f of c is equal to 1 over delta x times this integral from x to x plus delta x f of t dt. Well, hold on a second. This piece right here is exactly where we stopped. It's that piece right there. So here's what we're going to do. I'm going to grab another color so we can see all this. But look at this. C is some number. It's greater than or equal to x, and it's less than or equal to x plus delta x. Okay, that's what we know, 1. 2, we also know now, I'm going to come back up here. Let's do this. I'm going to grab that new screen now. Let's take copy. So this was our last step. And let's remember what we just said. We just said that all of that Copy. We go to our new screen here and going to paste it on there. And put it right up there. And let's turn this off, and there we go. This is what we left. But we just left with, this is the limit as delta x approaches 0 of, we just said that all of this entire thing is just some f of c. Okay, but look at this. C is bounded. It's the value on the left by x, and it's bounded above by x plus delta x. Well, if we take the limit as delta x approaches 0 of this entire statement, x less than or equal to c less than or equal to x plus delta x, well, what happens? This just says that c is between, this just says that c is bounded between x on the left and x on the right. So what is c? C has to be x. This is what we call the squeeze theorem. So by the squeeze theorem, the limit as delta x approaches 0, so let's write that out. F of x is the limit as delta x approaches 0 of f of c, but that limit is just f of x. C becomes x. So this is f of x. And that is exactly what we needed to prove. We needed to prove that opening statement that that if capital F of x is equal to the integral from a to x of f of t dt, if this, then the derivative of f, then f prime of x equals f of x. And that is what we have done. That is part 1 of the Fundamental Theorem of Calculus. I hope that helps. Thanks for watching.